Math 1, Unit 8.4, Solutions, numbers 7 through 12. Alright, so example, reflect about the y-axis, then translate up 2 units. So if we're going to reflect about the y-axis, we know our rule is y stays the same and x becomes the opposite. And then if we were going to translate it up 2 units, our x value would stay the same and we just go y plus 2. So that's what we're working on today, 2 transformations. Okay, so number 7, translate 5 units to the right and then rotate 90 degrees counterclockwise about the origin. So let's start with the translation 5 units to the right. Well, if we're going to go 5 units to the right, it means x plus 5. And since we're only moving 5 to the right, our y would stay the same. Okay? And then rotating 90 degrees counterclockwise. We know the rule when we're rotating 90 degrees, we switch our x and our y. And since we're rotating counterclockwise, it means our new x becomes the opposite. This guy is pointing at the x. If we had an xy here, well, this guy's pointing at the x value, so it means our new x becomes the opposite. Okay, number 8. Reflect over the x-axis, then translate up 2 units. So our first step is to reflect it over the x-axis. And the rule is when we're reflecting over the x-axis, the x stays the same, the y becomes the opposite. So that's the first step. And then, so we went from here to here, and then the next step would be from here to there. So translate up 2 units. So since we're only moving up, our x will stay the same, and our y, we will have to add 2 units up. Okay, moving on to number 9. Translate left 6 units and up 4 units, then reflect over the y-axis. Okay, starting with this one right here. So we're going to translate left 6 units. That would be x minus 6 will move us 6 to the left. And up 4 units, y plus 4. Okay, that's the first step. And then now reflecting over the y-axis. Okay, so when we reflect over the y-axis, we know that y stays the same, but your x has to become the opposite. This is where we have to be careful. So it's our current x, and this is our current x, so we have to put it in parentheses to show that this whole thing becomes the opposite. Alright, moving on. Number 10. Reflect over the y-axis, then reflect over the x-axis. So reflecting over the y-axis, your y stays the same and your x becomes the opposite. That takes us from here to there. And then reflecting over the x-axis. Well, this time, since we're reflecting over the x-axis, our new x would stay the same, but our y becomes the opposite. And when we reflect over the x and y axis, or in this case the y and the x axis, you'll notice we've talked about this, both the x and the y become the opposite. And this happens to be the same transformation if you do a rotation 180 degrees. You'll end up in the same place. Okay, moving on to number 11. Reflect over the y-axis, then rotate 270 degrees counterclockwise about the origin. Okay, so first reflecting over the y-axis. Remember when we reflect over the y-axis, the y stays the same and the x becomes the opposite. And here's a little trick. When you're going to rotate 270 degrees counterclockwise, it's the same as rotating 90 degrees clockwise. So we know when we rotate 90 degrees, we switch our x and our y. But since we're rotating this time, we're going to go 90 degrees clockwise. Our new y becomes the opposite. So the opposite of negative x is positive x. Okay? And number 12. reflect over the x-axis, then translate up 1 unit and left 6. Alright, so first we'll take care of reflecting over the x-axis, meaning x stays the same, y becomes the opposite, and then translate up 1 unit and to the left 6. Well, let's start here with left 6. That would mean x minus 6, and up 1 unit would mean negative y plus 1. Okay, moving on to number 13. It says reflect line segment AB over the line x equals negative 2. Vertical lines passing through the negative 2 on the x-axis. So what they're saying here is here's your x equals negative 2. So we're going to draw that line of reflection right there. Alright, so if we're going to reflect AB over this line, the easy thing, since it's a vertical line, we find out the vertical distance between the line of reflection and A. That's 1, 2, 3. So we know A prime is going to be back 1, 2, 3 right there. That'll be A prime. And then from the line of reflection, B is 1, 2, 3, 4 spaces. So B prime will be 4 in the other direction, or 1, 2, 3, 4. And that's B prime. And then we can just connect the dots. And it would be better if I had a straight edge handy, but I don't, so there we go. Okay, now writing the rule. We talked about this when we did reflections a few days ago, but if we want to make a rule that works for the y-axis in comparison to the x equals negative 2, they're both vertical lines, here's how it works. We know when we do a reflection, we switch our x and our y. Since this is a vertical line that is like the y-axis, we switch our x and our y, but we know our new x becomes the opposite. Okay. Oh, I'm so sorry. I'm doing a rotation. Let me start that again. X, Y. Okay. When we do a reflection, our x and our y don't switch. That's on a rotation. When we do a reflection, since it's a vertical line, which is like the y-axis, the y stays the same, but our x becomes the opposite. Okay, but since it's not the y-axis, it's the x equals negative 2, I told you the trick is you multiply negative 2 by 2, and that is added on to your x. So what it really becomes is negative x minus 4, because negative 2 times 2 is negative 4, and that's y. And we can test it out. Let's look at A. A is at 1, 3. And if we follow our rule, let's see. Plug in 1 there. That becomes negative 1 minus 4 is negative 5. And the 3 is unchanged. So here's A, and this is A prime. Let's see if it's at negative 5, 3. From the origin, 1, 2, 3, 4, negative 5, 1, 2, 3. It worked. Let's check out B. B is currently at 2, negative 2. And if we follow our rule, we plug in 2 right here. So 2 becomes negative 2 minus 4, which is negative 6. And our y is unchanged. That's B prime. Let's see if B prime's at negative 6, negative 2. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 1, negative 2. And there it is. So the rule works. If you see this rule on the test, it will be most likely an extra credit problem.